Hi, everybody. Welcome back to Earthly Headlines. And I just came across this article on hakaimagazine.com, and it's super mind-blowing because it's something that I'd never even considered through all my years of reading scientific articles, and that revolves around footprints and the information they could give to researchers. And it makes a lot of sense after having read the article, but just thinking about it for 5 minutes. So Andrew Curry, he wrote this awesome article on hakaimagazine.com. It's right here on the monitor, and he lays out very eloquently not only how important footprints are, but also where they're found, how rare they are, like their fleeting lifespan. And also, he details 3 examples of different scientists finding these footprints in the most unlikely place, which are beaches. That blew my mind, because how ephemeral are footprints at the beach? If you've been to the beach, you walk along the shoreline, within 20 seconds, they're gone. Apparently, ancient people left quite a bit of footprints that were somehow preserved at these shorelines. The author opens up, Mr. Curry, he opens up this article with this individual who we'll talk about later. He's an expert in animal prints. One day, I think off of the coast of South Africa, he finds giraffe prints. And yeah, they're giraffe prints, right? Whoop-de-doo. He was able to extract all kinds of information from just those giraffe prints. So the fossilized footprints that he found recreated a vanished world full of lions and elephants, buffalo, and horses. He even found giraffe tracks, evidence that the landscape was dotted with trees. One giraffe track and you have an entire paleo-ecological reconstruction. You get the sense it's teeming with wildlife. And that is true. If you find a giraffe print, there are probably a lot of trees around. That makes a hell of a lot of sense. If you were just some guy or girl who didn't know any better and just saw these giraffe prints, you'd be like, oh, giraffe prints, and then you just be on your way. But in this case, if you come at it with a scientific eye, it fills in all of these blanks all these gaps in your knowledge of the area, or your knowledge of the prehistoric area of South Africa, in this case South Africa, in which previously they were just left blank. So the fact that he just found these footprints and was able to reliably fill a lot of these holes is a huge asset to the scientific community. So anyway, I was geeking out over this, and right away I immediately saw the significance of these footprints. What these scientists share in this, there are these 3 different groups of scientists that I'm about to get into. They all found human tracks. So human tracks, that's even more interesting, because they're people like us leaving their tracks much in the same way we do now. Except they probably weren't wearing shoes like us. They were just barefoot. And I'm sure their footprints that they left encode a lot of information that, again, just like in the giraffe example, we've never even thought about. So a huge group of these people, they gathered in this conference in Cologne, Germany, 2016, 2017? And they all compared notes, and they wanted to pick each other's brains and see where these discoveries can lead to. See what this can lead to, and how they can better not only preserve, but where they can start go about looking for these places. And there were a variety of footprints that people found from different places. For example, one group found them in fossilized lake beds in Saudi Arabia, which is right on fossilized lake bed. Of course, stuff like that would be preserved for a while. Another one they found in France inside like deep caves. And again, deep caves that are unexplored for hundreds of thousands of years, more than likely than not, it's going to stay the same. It won't change much in those millennia. And then the oldest one that they have ever found was in Tanzania, which is basically somebody walked through wet volcanic ash, and then it just hardened. That was 3.6 million years ago. So some hominin was walking around a semi-recently exploded volcano, and they left their footprints there that are still there even now. Modern beaches have become, like I said, a hotbed for these footprints, and these are just 3 examples that I'm sure more in the future. Okay, so the first example that I want to go over, the one in England, I think, Haysborough. It's spelled phonetically Happisborough, but it's pronounced Haysborough. Let me just pull this up here. So here we go. Oh, before we get into that though, the reason why beaches are so ideal to preserve these footprints is because coastal regions the sand is very malleable, so it's very easy to leave footprints. And also, once the footprints are there, it's very easy for wind to blow sand over the soft, I guess you would call clay, and it hardens over it, and it kind of creates a cast and makes the footprint just stay imprinted in the ground underneath that cast, and it takes a storm or a high tide or something to make it disappear just as easily as it did appear. But up until that happens, something's gotta interfere and peel that cast off. And that's why whenever scientists, whenever a storm passes through, right after the storm is over, they go out there and search, and they see what else has come up. I just want to get that out of the way before we go further. But imagine finding a human footprint, and imagine all the clues you get to their activities, how fast they traveled, their height and weight, and even their gender. That's a lot of information you can get that you may not even get from finding a bone. At least not all of it, not reliably. The first place I want to talk about is this place that I mentioned earlier, Haysborough. Well, first of all, Haysborough is in Great Britain, actually 200 kilometers away from London. Here's a good picture of the human footprints, almost 1 million years old, that were recently revealed by the storm. So yeah, that's incredible. But it won't be there for long. It's probably not even there now. It's probably completely gone now. So, the scientists have to get in there and work pretty quickly before it all disappears. Okay, well anyway, in Haysborough, this guy, what's his name? Nicholas Ashton. That's his name. Nicholas Ashton. He was in Haysborough, and he's trying to study the estuaries that were known to be found in Haysborough. He's found ancient estuary beds dating back millions of years. He talked to a dog walker who found a hand axe near the beach, and Ashton dated that to be 500,000 years old. And in between when he found these prints and when he found all that other stuff, other archaeologists found bones, antlers, and all kinds of stuff, animals left behind around there, including a mammoth, by the way, which is really interesting. A mammoth on England, which is super fascinating. So this guy Ashton, he comes across this the footprints, and he says, according to him, he only had a few hours to document the tracks before the next high tide further eroded the hardened mud layer containing the footprints. He couldn't dig them up and move them either. If you're wondering, the first thing I wondered was, why didn't he just cut a square into the earth and then just pull it out? Well, that's a lot harder, and it's a lot easier said than done. And because number one, it'd weigh a lot. It'd weigh about like 50 kilograms at least. And you're only one guy, and you're working against the clock. You don't have the time to do that. So what he did was he took a bunch of photos. He took as many photos as he could, and then using computer technology, he kind of recreated a 3-dimensional image of all the footprints that he could. So that's a lot of work. I can barely take a selfie and decide on what selfie I want. This guy spent hours just taking photos from every single angle that he could think of. And again, in rain, in mud, it was just all damp and wet, and he couldn't have time to even think. He just had to go. So he recreated this image, and then he extracted all this data. What he extracted was, one, there were nearly 50 footprints, and they were clear enough to distinguish 5 or 6 different people. So based on the length of the prints, he estimated the height of the individuals, because feet are roughly 15% of a person's height. I mean, that was news to me. I didn't know that, but that makes sense. That's why Shaquille O'Neal has giant feet, right? And then he passed off this digital reconstruction to another anthropologist, and she came to the same conclusion. She said there was probably about half a dozen people running around the mud, including children. So this might have been most likely just some family hanging out on the shoreline. And again, you can't get this information from a bone or like some type of remains. There's no way. You could only get this from footprints, and by carefully, meticulously analyzing everything. And that, of course, I'm sure there's more to it, like superimposing it with other information, like geological information and what the weather would have been like back then, and other things. This archaeologist that I mentioned, or this anthropologist rather, Isabelle de Groot, that's her name. She thinks that they're one of the most ancient species of Homo, which is Homo antecessor, which most people aren't sure what they look like because there's no complete Homo antecessor found, but they think they were tall, with males averaging 175 centimeters and females 160, and not very different from us. About this species Homo antecessor, bones have been found in Spain, that part of Western Europe, and Haysboro rather is not quite where Spain is, obviously, but it's right there in the vicinity. They dated these to about 900,000 years ago, so they were not anatomically modern humans, but they were people related in our not in our species, but in our family, the family of Homo, the genus Homo rather, that were hanging around a million years ago. And if you found a stone tool, you wouldn't be able to come to those conclusions again, which is completely mind-blowing. This Haysboro case is a good example of how a specific set of circumstances can come together to preserve footprints for millennia. They were just like the footprints were lucky to have been preserved this long because, again, it's like a Goldilocks situation. There wasn't too much it wasn't too harsh of a condition, and the sediments of mud, clay, silt, and peat just worked just fine to protect them. They need to be soft enough to make the prints, but not too soft, or else the print won't retain its shape, obviously. So here is the footprints that show the orientation and direction of them, and I want to get into this because this is super interesting. This little resulting picture. So there was a pattern of movement to the south, but no clear trails, as you can see. And the footprints aren't marching in line. It's almost like they're wandering this way and that way and stepping past and behind each other. And again, it's the family walking along the estuary and behaving the way families behave. Children running around and doing circles, skipping around. Maybe the adults have a watchful eye on them, but they're probably, holding hands, something like that. I don't know if they held hands back then, but maybe. That wouldn't surprise me. It seems like such a natural, a no-brainer to hold the hand of your loved one. But then again, I'm biased because I'm a modern human living in modern times. The other thing, I'm sorry, that I went off on a tangent there. So this discovery offers a possible answer to one of the questions archaeologists have long wondered, which is, how did such an early species survive the cold in Northern Europe? That's the first thing I asked myself when I was reading this. How did they survive? They're a family, so they weren't sent out by a tribe to go explore that frigid area of England, which at the time wasn't an island back then. It was connected to the mainland because the sea level was lower. So what was going on up there? It would have been freezing, but a family with children up there, and meandering like it's no big deal. There's a lot of questions here that would have never come up if they didn't find these footprints. Let's see. Here's a reconstruction of what they might have thought this guy would look like, and he looks very similar to us, right? Very, very similar. Okay, so I think that's about it for this example. The next example is Calvert Island, which is, I think, right here. So here's one of the footprints they found. You can barely make it out in here, but it's there. It's there. So this other guy, Duncan McLaren, he's the scientist that was working off Calvert Island, which is off British Columbia in North America. And this is not crazier, but this brings up a whole nother issue into question, which is the peopling of North America. The conventional... Well, before we get to that, let me just talk about what happened first. So this guy McLaren, he and his team, they weren't even looking for footprints. They were just looking for ancient shorelines that dated between this specific period, 13,000 to 10,000 years ago. And when he did come across them, he took it for granted. He didn't even know. He knew what he had. He didn't really know the implications of what he had. All he knew is that they're footprints, and whoop-de-doo, they're footprints. So obviously that wasn't the goal for him. So anyway, he comes up with his team, which also included descendants of the first peoples in North America, which is an actual group in Canada. And they took samples from the footprint, including bits of wood and other organic matter that had just so happened to be pressed into the earth. They carbon dated it, and they found that they were older than 13,000 years, which, if you know anything about the whole debate raging about the peopling of North America, that throws a huge monkey wrench into the quote, the mainstream, the widely accepted hypothesis, which is the Bering Land Bridge, where people followed, allegedly, if you don't know, people from Asia and Siberia, they crossed the land bridge after they followed woolly mammoths over once the land bridge became passable, and then they peopled North America that way. It makes sense if you don't know anything about the recent discoveries, but this is just another example of the growing examples of people finding bones that predate the supposed ice-free corridor and all that stuff. Over 13,000 years, that's way before the supposed crossing of the land bridge people. Not to say that the land bridge, that migration couldn't have happened. It definitely could have happened. No doubt about it, it could have happened. But they weren't the first. They already found bones of people that were already there. So right away, that hypothesis becomes problematic and probably should be thrown out. But that's another video. Okay, so Calvert Island, they carbon dated the organic material, and again, they revealed 28 prints. It belonged to another family, 2 adults and a child. They were created the same way. They left their feet. They pressed their feet into the wet, firm clay, and then not long afterward, black sand and pea gravel washed into the depressions, filling them up, and there they hardened until him and his team came and found them. So thousands and thousands of years. So McLaren's discovery It's circumstantial evidence of there being people. It's not, I guess it's not considered smoking gun evidence, because for a number of reasons, I'm sure a lot of people dispute the numbers. I'm sure a lot of people dispute radiocarbon dating, period. It doesn't add up when you consider all the other evidence that they found of people already in North America. The Clovis first theory definitely has a lot of holes, a lot of gaping holes. It's probably worth mentioning that this alternative hypothesis to the Clovis first model is that humans were in the Americas as early as 15,000 years ago, at a time when the Bering Strait was a land bridge, but the evidence suggests early Americans also traveled by boat. Okay, so island hopping from Asia to the Pacific coast of Canada, those early proto-Americans, I guess what you would call, must have had some type of seafaring capability, because otherwise how else would they get how else would they island hop? There's no way. They can't swim across that kind of they wouldn't even think to swim across to get to the other side, to another island, especially if they already had food, and especially they were living off of fish, which is what they were doing, definitely. And this is not a new idea of ancient people having boats. I think the first boat ever found, like the oldest boat rather, was about 38,000 years ago around Australia. And those people somehow, the indigenous people of New Zealand and Australia, those people, there was evidence of, if I recall correctly, they successfully sailed to Madagascar or somewhere super far and super crazy across the Indian Ocean. So anyway, back to Calvert Island. The Kelp Highway hypothesis, as it's called, suggests boating and seafaring ability, like I said. Some people stayed, and some people kept going south, down toward the present-day United States and South America. And the ones that stayed lived off fish and lived off the land, which is probably where these footprints come from, that population of people who stayed. And all this points to, indirectly or again circumstantially, that those people we've got to give them more credit than them just being hunter-gatherers. I mean, they must have had some type of skills and knowledge and techniques, and that those kind of things don't just pop up randomly. It's not like a random thought in a random hunter-gatherer's head to make a boat. They probably must have had a long-standing tradition that individuals must have shared these skills somehow, and it must have been part of their culture. The third example I want to get into, I don't want to drag this out too long, Brenton-on-Sea Cave, which is in South Africa. These tracks he found are 90,000 years old, and again, they were the footprints were made the same way. Running down dew-kissed dune, pressed their feet into firm sand. Before the footprints dried and collapsed, the wind picked up sand and blew it into the depressions. And then over thousands of years, the sand was packed into aeolianite, which is a type of limestone formed from coastal dunes. So not only was this a sand that filled the gaps, the depressions, but this like a limestone. Basically, limestone formed over these things. It was, again, incredible. And then the rising seas eroded it, and this guy, he and his wife and some other guy, some other guy and his wife, they just by chance, they run into these prints. He used a camera, he documented the tracks, and then he recreated a 3D map of the footprints. And here's what they found. First off, they're 90,000 year old footprints these ones belong to Homo sapiens, for sure. So these are our people. This is us. 90,000 years ago. Just to put that in perspective, the next modern human footprints, the next oldest, are 44,000 years. Okay? 44,000 years after these people lived were the next ones. That's a long time. I don't need to tell you that, but I just did. I guess the big takeaway from this article is the fact that footprints should not be underestimated. And I think more and more scientists, especially young scientists looking to make an impact in the scientific community, they should start gathering their colleagues and start storming beaches that are rumored to have these footprints. Lord knows what else they could find out there, and I'm sure there's way more stuff out there. And think about the average person. Even just today, the average person takes about, what was the figure? 224 million steps in their lifetime. 220. Yeah, is that right? 224 million steps. That's the modern person. Imagine a hunter-gatherer back then, who all they do is walk around. Well, allegedly hunter-gatherer. They might not even have been hunter-gatherers. But for the sake of this video, we'll say that they were hunter-gatherers. This is a picture of the guy taking a photo. This is the limestone. That thing on the ceiling is the limestone deposit. So he's taking the picture from the bottom up. That's the angle he's using. Incredible how this is a natural formation, and it just by sheer coincidence it time capsuled those footprints for us to see. Anyway, yeah, we shouldn't, not we, by we I mean us as scholars and readers of science, and as well as those people studying ancient, I mean anyone in the scientific community, obviously, they should immediately start looking for these footprints, because this is actually, no one thought to look for footprints at the beach. No one ever thought about that. So now that it's out there, we can only hope that people are doing the Lord's work out there, and they take a cue from these guys, from these examples, and they search for themselves. I'm sure they'll find something. All right, thank you so much for sitting through this and listening. I hope it helps you guys, especially the people who are busy, who don't really have the time to really think about this and read about this. I'm going to post these. If you do want to read this yourself, if this has intrigued you enough, I will post the links in the description below. And please visit the Twitter. If you have Twitter, just follow me. I'm going to post these up as regularly as I can, because I read these anyway, and I'm just enthralled, and I love telling people about this. So have a good day, and stay tuned for more.